Here we go, guys. Test 6 review. The first topic we covered was literal equations, which is basically equations with a bunch of letters in it. That's where we get our literal from. And we're just rearranging to solve for a variable of interest. And so in our first equation, number 1, we are solving ax plus by equals c for b. Remember, when you're solving, we're going to use inverse order of operations. So instead of PEMDAS, we'll go backwards, starting with subtraction and addition. So we're identify the variable of interest, that's b, and we're moving everything away from it in reverse order of operations. The by is attached. We need to get rid of the ax first. Okay. Reverse order of operations, look for any addition and subtraction to undo. So we undo our positive ax by subtracting ax from each side. You're left with by equals c minus ax. We still want to isolate b, so we need to get rid of our y. b times y, the inverse of multiplication is division. Divide both sides by y. You're left with b equals c minus ax over y. Number 2, we're solving this equation for m. So you identify your variable of interest. Then we want to eliminate everything else from that side of the equation. You have 2 choices. You can either start by eliminating the 1/2 or the v squared. I chose to eliminate the 1/2 first. In order to divide by 1/2, you multiply by the reciprocal, which is 2. So we multiply each side by 2. K times 2 is 2k. 1/2 times 2 simplifies to 1. Again, identify your variable of interest. We're looking to eliminate the v squared. Well, we have m times v squared. The inverse of multiplication is division. Divide both sides of your equation by v squared. We're left with 2k equals v squared. 2k over v squared equals m. Our third equation, a force equation, F equals g times m1 times m2 divided by d squared. Identify your variable of interest. In this case, it's m2, or the mass of the second object. We're going in reverse order of operations. Well, there's no addition or subtraction that we can undo first. So now look for any multiplication or division. In order to get rid of the d squared, the inverse of division is multiplication. You multiply both sides by d squared. F d squared equals g m1 m2. Again, identify your variable of interest. We're looking to eliminate the g and the m1. Well, since they're both the same operation, they're both multiplying, we can divide by g m1 on both sides. You're left with fd squared divided by gm1 equals m2. We've now solved for, or create an equation to quickly solve for the mass of the second object. All right. Our second topic, and one we spend a little bit more time on, is linear programming. We can use linear programming to maximize or minimize a certain variable of interest, right? We might be maximizing or minimizing profit or cost, or we'll see a problem on the back side of this review where you're maximizing points scored. The key is to get into the word problem, identify all the information you can, and then work slowly to pull out our constraints, pull out our objective function, and go from there. So here we go. We have a small company producing knitted afghans and sweaters. An afghan's like a scarf or a blanket, and selling them through a chain of stores. The company is to supply the stores with a total of no more than 100 afghans and sweaters per day. So that's no more than a total of 100 afghans and sweaters together. Okay? That's a restriction, no more than. Okay? So in that case, we know we're dealing with one of our constraints. When you see no more than, or at least, or a total of, you know that you're looking at one of your constraints. So identify that. That's a constraint. The store guarantees it will sell at least 10 and no more than 60 afghans a day. Again, there's some words that tell you you're being restricted or constrained in this situation. At least 10, no more than 60 Afghans per day. So that's a constraint. Constrained in this situation. We can't sell as many Afghans as we want. We can't sell 0. We have to fall within these boundaries or these constraints. And at least 20 sweaters per day. So there's another constraint or boundary. Right? And so when we talk about constraints, we're looking for words like at least, no more than, a total of, right? Anything that tells you you have to do something or you're not allowed to do something. Right? The company makes a profit of $10 on each Afghan and a profit of $12 on each sweater. And all we're asked to do here is to write the constraints. Well, let's go back in and say, okay, well, where were those boundaries or those restricting phrases? A total of no more than 100 Afghans and sweaters per day. So when you add your Afghans and your sweaters, they have to be less than or equal to 100. So we write a constraint for the total pieces sold. X plus Y is less than or equal to 100. X can be whatever you want. Y can be whatever you want. When we get to our next constraint, at least 10 and no more than 60 Afghans per day, we'll now write some constraints that follow these guidelines. So we said at least 10 Afghans. So you can have 10 or more than that, but you have to have at least 10. So X is greater than or equal to 10. No more than 60. So X is less than or equal to 60. If you chose Afghans to be Y, that's totally fine. It left it open-ended. It was completely up to you. And then our final constraint here was that we had to sell at least 20 sweaters per day. That is the least number of sweaters you can sell. You can sell 20, you can sell 21, you can sell 400 for all we care, but at least 20 have to be sold per day. And so we write a constraint that was talking about our sweaters here, that Y must be greater than or equal to 20. And those are your constraints for this knitting company. Didn't ask you to do anything more than that. When we look at number 5, they give us an objective function to represent cost. Right? C in this case represents cost, and we say the cost is equal to 5 times X plus 2 times Y. It doesn't give us any context or any more information. It just says that your cost follows this equation. Then it asks you to use the graph to determine the maximum and minimum cost. Well, we learned this week that your maximums and your minimums will happen at vertices. Right? So we're going to look for our vertices here. Vertices being the plural of vertex. Okay, another way to think about that is look for the corners of your feasible region. Right? It gives us a graph, so we don't have to graph it. We don't have to shade. We don't have to do anything but identify our vertices. This is where all of our constraints come together. Again, we didn't know the constraints, but that's fine. This is where all of our constraints come together. And then take those points, those XY combinations, and plug them into your cost function. And so our first vertex was 2, 2. We take that and plug in 2 for X, 2 for Y. We end up with a cost of 14. And you do that with each point as you go. Right? This vertex was 8, 8. So we went here and we took 8 for X, 8 for Y, plugged in 8, plugged in 8. We got a cost of 56. When you do that for each and every vertex, you can see the cost at those production points. Right? If your X was 4 and your Y was 2, plug in 4 for X, 2 for Y, and you get a cost of 24. It asks for the max cost and the min cost. And in this case, we found that our min was 14 and our max was 56. So whatever company this was, as they're doing a cost analysis and trying to understand their production process, your maximum is 56 and your minimum is 14 possible dollars. as we look onto the second page of our review, okay, number 6 asks us simply to graph the system of inequalities. So we learned this week that we can graph a linear inequality, right? You just treat this as if it was y equals 1/4 x plus 6. That's your slope-intercept form, your y-intercept being 6, your slope being a positive 1/4. Graph that line and then make a choice on how you're going to shade. Less than indicates we'll shade below. So we went to our y-intercept of 6, our slope of positive 1/4. We start here, we go up 1, right 1, 2, 3, 4, up 1, right 1, 2, 3, 4. You want to go the other way, right? So both will be negative, down 1, left 1, 2, 3, 4. And you graph your line that way. And then we have to choose where we're going to shade. If you less than, we indicate we shade below. Since we're graphing a system, we're going to check where to shade, but we're not going to shade till the very end. We want to shade the area that satisfies all of our inequalities. Okay? But for that first linear inequality, and that's our black line here, you see the arrows telling us and reminding us that at the end we'll shade below. Our second inequality, x is greater than or equal to 2. Start by graphing the line x equals 2, which we know is a vertical line. X equals 2. And then which way do we want to shade? Well, if it's greater than, we don't have an above and a below because the line's vertical. But what space tells us all of our x's will be greater than 2? Well, 3 is greater than 2, 4 is greater than 2, 7 is greater than 2. So we would shade to the right. Our last inequality, y is greater than or equal to 3. Graph the line y equals 3. That's a horizontal line. Straight across at y equals 3. Because it's greater than, we shade above. And so we made our arrows, our marks, to remind us, okay, we want to stay above the red line. And when we graph the system, we have to shade the area that makes them all true. And that's called our feasible region, right? What is the area where all of the points will satisfy all of our inequalities? We need to share the area above the red, to the right of the blue, and below our black line. And that turns into this area here. And that's our feasible region. Notice it's unbounded going to the right, right? We would keep shading here. There's no constraint that tells us we can't shade this way. And that's just the system of this inequalities. All right. Finally, our last question asks us to do a linear programming question all the way from start to finish. So we're going to walk all the way through this process. It tells us that our next exam is multiple choice and short answer questions. Time permits you to answer no more than 9 questions. You must answer at least 3 multiple choice and at least 2 short answer. Then it tells us that multiple choice questions are worth 15 points and short answer questions are worth 25. So it walks us through, okay, what do X and Y represent? Write your objective, create your constraints, and graph your inequalities. And so sometimes it's really easy and obvious to start with defining your variables. Sometimes it's easier to write the objective first. In this case, we might need to think about, well, is it time? Is it short answer? Is it multiple choice? Is it the points? Okay, and so start with writing your objective. Well, what's our goal here? Objective means goal. What's our goal? Well, on a test, your goal is to maximize the number of points you score. And so let's write a function that maximizes points. Well, we know that we get 15 points for each multiple choice question. So 15 times x tells us that that's all of our multiple choice points will come from put the number of questions you do multiplied by 15, and then 25 for your short answer. So 25 points times every short answer question we get correct, and that's where your objective function comes from. Okay, up until now, most of our questions have been profit or cost, dealing with money, but that's not always your goal. Sometimes your goal, like in this case, is to maximize the number of points you can score. Okay, if you had X as short answer and Y as multiple choice, that's totally fine. You would have 15Y plus 25X, and that's completely okay. All of your inequalities would be inverted from what we do here, but that's totally fine. You'll get the same maximum at the end. Now we need to create a system to represent our constraints. So let's go back into the question and say, okay, what are our boundaries? What are the things we're restricted by? Why wouldn't we just answer every question and get all the points possible? And so let's walk in here. The first sentence says, time permits you to answer no more than 9 questions. So we have a restraint here because we will run out of time. And so our restraint is that we can answer no more than 9 questions. So all your multiple choice plus all your short answer can be no more than 9. So X, your multiple choice questions, plus Y, your short answer questions, have to be less than or equal to 9 total questions. Let's find our next restriction or constraint. It tells us that we must answer at least 3 multiple choice, right? So we can't answer 0 multiple choice. Why not? Let's answer all short answer. They're worth more points. But the test tells us we have to answer at least 3 multiple choice. So that's a boundary or restriction. So, okay, X, your multiple choice questions, has to be greater than or equal to 3. And then our final constraint or our final restriction is that we have to answer at least 2 short answer questions. Right? So that's a restriction. You're bound to having to do that. We'd say, okay, let's write a constraint for our short answers. Y must be greater than or equal to 2. If you have to answer at least 2, then Y would have to be greater than or equal to 2. The next step would say, okay, let's graph this system of inequalities. Let's get it over here and find the vertices and go to work from there. And so in order to graph our first linear inequality, we need to put it in our slope-intercept form. Okay, so move the X over. Y is less than or equal to negative X plus 9. You could also do this by finding the X-intercept and Y-intercept. That'd be totally fine as well. Yeah, but if we're graphing linear inequalities, we know we can also do it using your slope-intercept form. So Y-intercept is 9. Slope of -1, down 1, right 1, down 1, right 1, down 1, right 1. And you create this line that has a perfect -1 slope. Which way are we going to shade? It's less than, so we'll shade below. So we put our arrows in to remind us to shade below this black line. Our next constraint is X is greater than or equal to 3. So we graph the line X equals 3, which is a vertical line on 3. It's greater than, so again, we're going to shade to the right of that blue line. And then finally, we have a horizontal line. Y is greater than or equal to 2. So we graph our horizontal line, Y equals 2. It's greater than, so we know we shade above. And once we have all of our inequalities onto our graph, we then shade our feasible region. Right? That's the area that satisfies all of our constraints. And then finally, number 11 asks us, how many of each type of question should you answer to earn the most points? Given all of our restrictions, okay, we can't just answer every question we want. Given these restrictions, how many of each should we answer? Well, we know that we maximize our points by going to the vertices. It's going to happen at a corner. We don't know which one yet, but it's going to happen at one of the corners. So go find your vertices. 3, 2 is a vertex, 7, 2 is a vertex, and 3, 6 is a vertex. Take those XY pairs, plug them into your points function. So 15 times 3 plus 25 times 2 is 95. 15 times 3 plus 25 times 6 is 195. 15 times 7 plus 25 times 2 is 155. Well, what's the maximum points we can earn? It's 195. That's not what the question asks us. Remember, the question says, how many of each type should you answer? Well, let's go back and look. Well, our X was 3 and our Y was 6. That means 3 multiple choice and 6 short answer questions.